In this video, we will discuss HL congruence, which is when two right triangles can be proven congruent when the hypotenuse and one leg of one triangle are congruent to the hypotenuse and one leg of another triangle. So in this case, our hypotenuse is the largest side of the triangle across from the 90-degree angle, and then we need one leg to be congruent. That is how HL works. So if we take a look at example 5 down here at the proof, okay, we will see that we have two triangles here, and it shows that we have AB is perpendicular to DC is our given. Segment AB is perpendicular to DC. So if we know that we have segment AB and it's intersecting segment DC, and perpendicular means that it forms a 90-degree angle. So we can circle that and say forms a 90-degree angle. Okay? And so notice now I have two right triangles. And because I have two right triangles, I can probably use HL congruency. So we also notice that both triangles ADB and ABC share a side, which means that this side is congruent. And if you recall from previous videos, by reflexive. So we're probably going to have a reflexive property somewhere in our proof. Now let's take a look at the proof. We're trying to prove that triangle DAB is congruent to triangle CAB. Haha, it works out nice. So our first thing says it's given, so let's write our given statement that we have. We have two givens because we have the perpendicular, but then we also have the two sides that were given as well in our picture here. So we can say that segment AB is perpendicular to segment DC, but then we can also say that segment AD is congruent to segment AC because of the picture showing us the two tick marks. So this and this is also our given. Okay? And notice how I'm labeling the picture and making sure I have all of my parts before I do the proof. Now, our next part says definition of perpendicular. Well, the definition of perpendicular means that triangle DBA, or not triangle, sorry, angle DBA and angle CBA, or ABC, are right angles. I'll just squeeze that in. And we know this to be true because that is the definition of perpendicular. Perpendicular states that two lines that intersect each other will form a right angle at the intersection, which is what's happening at point B. Now our next thing says that triangle DAB and triangle CAB are right triangles, and the reason we can say that is because of the definition of right triangles. A right triangle exists if it has a right angle by definition. Now step 4 is going to be that reflexive piece, so we're going to say that segment AB is congruent to segment AB, and we're going to say by the reflexive property. Okay? And because we have a leg of our right triangle that is congruent to a leg of our right triangle, and the hypotenuse, which is the side across from the 90, so this is the hypotenuse, are congruent, which was our given, we can say that triangle DAB is congruent to triangle CAB by hypotenuse leg, or HL. All right? We're going to do example 6 now. Now notice example 6 is another example that is completely blank, so you get to do what you want to do. Okay? So some things to start with is by looking at our picture and saying all of the givens that we can get from our picture. So my first reason is going to be given. And let's go through and see what we were given. We were given that AD here is congruent to BC because of the tick marks. So that's a given. We were also given that angle D and angle B are 90 degrees or a right angle, and that's also given. Oh, sorry, we don't know it's 90 degrees yet. We know they're right angles. So we can write that in our givens. We can say that angle D and angle B are right angles. We can also say that segment AD is congruent to segment BC. Okay? And if we see across from our 90 here, AC is our hypotenuse, but both triangles have AC, so we're probably going to have AC is reflexive at some point. And that's the little extra note we should make, segment AC. Okay? So if we keep going, we can say that triangle DAC and triangle BCA are right triangles because they have a right angle, and that is by the reason is the definition of right triangles. Okay? Similar to the example we did above, once we knew there was right angles, we could say the triangles are right triangles. And if they're right triangles, then they have a hypotenuse and a leg. And so now our reflexive property is going to come into play because we already have our leg, so we just need the hypotenuse in our proof. So we can say segment AC is congruent to segment AC. Ooh, my pen is dying. And we can say that because of the reflexive property. Which means that now I can say that triangle DAC is congruent to triangle BCA because of hypotenuse leg. Because I have the hypotenuse and I was given that the legs are congruent. And with that, we have successfully done the proof to prove that triangle DAC is congruent to triangle BCA.